Hello everyone, welcome to Physics and Rapid YouTube channel. In this channel, you will get concepts related to physics as well as PYQ of various examination. In this video, I am going to explain Lagrangian and Hamiltonian formulation. Before going to Lagrangian and Hamiltonian formulation, let us see what is generalized coordinate, generalized velocity as well as generalized momentum. Generalized coordinate is represented by the symbol qi, and generalized coordinate, it is a independent quantity. It does not depend on the any quantity. Okay, I can define generalized coordinate like this: dou of qi divided by dou of qj is nothing but delta ij, where I, which is equal to j, means its value, delta value will be 1. I is not equal to j means delta value will be 0. So, generalized velocity can be defined as it is the rate of change of generalized coordinate. It is the rate of change of generalized coordinate. So, the symbolic representation of generalized velocity is nothing but qi dot. So, how I can define it as the total time derivative of generalized coordinate. Next, generalized momentum. Generalized momentum symbolic representation is pi. How I can define generalized momentum is it is a partial derivative of L with respect to generalized velocity. It is partial derivative of Lagrangian. L means Lagrangian with respect to generalized velocity, that is qi dot. Okay, so the mathematical expression for generalized momentum will be pi is nothing but it is a partial derivative, means dou L divided by dou qi dot. Okay, now we got to know about the generalized coordinate, generalized velocity as well as generalized momentum. Okay, now we shall define what is Lagrangian. How we can define Lagrangian? Okay, Lagrangian can be defined in terms of it is a depending on generalized coordinate, generalized velocity as well as time. So in a simple definition, I can write Lagrangian is nothing but difference of kinetic energy minus potential energy. It is the difference of kinetic energy minus potential energy. One more thing we need to remember here carefully, that Lagrangian is a suitable function of generalized coordinate and generalized velocity. This is generalized velocity, this is generalized coordinate, and it is also a function of time. Okay, next we are going to Hamiltonian. The symbolic representation of Hamiltonian is h. In the previous slide only, I showed that the symbolic representation of Lagrangian is capital L. The symbolic representation of Hamiltonian is h. In the similar way I defined Lagrangian, the Hamiltonian I am going to define now. So, Hamiltonian is a function of generalized coordinate. Instead of generalized velocity, it will be momentum, generalized momentum and time. So, the equation of motion for Hamiltonian can be written as, or the mathematical expression is, Hamiltonian is nothing but summation over I pi, that is a generalized momentum, into qi dot, that is a generalized velocity, minus Lagrangian. This is the expression for Hamiltonian. This is very important while solving the problems. And we have one more important equation of motion for Lagrangian, that is called Euler's Lagrange equation of motion. This expression is very important for solving problems. We need to remember this. Okay, let me write the mathematical expression for Euler Lagrangian equation of motion. It will be total time derivative of partial derivative of Lagrangian with respect to velocity minus, that is difference of partial derivative of Lagrangian with respect to generalized coordinate qi, v is equal to 0. This is a very important expression, or you can call it as a Euler's Lagrangian equation. This expression is very important while solving the problems. Next, we will move on equation of motion. On seeing the equation of motion, we can tell the dynamics of the system. Okay. When qi double dot is equal to constant, means qi double dot is nothing but it is the acceleration in terms of a kinematics. Here it is generalized acceleration. So qi double dot, which is equal to constant, means it is a uniformly accelerated motion. If qi double dot, which is equal to 0, means it is a free particle. The dynamics of the system is nothing but free particle. It is similar to the kinematics only, but here the language is different. So qi double dot is equal to minus c qi represents, it is the dynamics for simple harmonic motion. I am considering a c to be greater than 0. A c is a constant. Coming to next, qi double dot is equal to minus c to function of generalized coordinate. This represents it as a oscillatory motion. If a function of generalized coordinate is a odd function, means then it will be oscillatory. If it is a even function, means then it will be non-oscillatory motion. Then coming to next, qi double dot is equal to minus c into qi. Qi is here generalized coordinate minus c prime. This is some constant. Qi dot, that is a generalized velocity. This equation of motion represents damped oscillation. Then qi double dot, which is equal to minus c into qi, plus or minus, if it is a function of time, it is a function of time, plus or minus function of time, means it represents the forced oscillation. And these equations of motion are very important. They will be asking direct questions from this equation of motion. They will ask, they will give you the equation of motion. We need to mention the dynamics of the system. Okay, let me move to the next slide. We have two important equations of motion. Two important equations of motion, or else we can call it as a Hamiltonian equation of motion, or we can call it as a canonical equation of motion. qi dot, that is generalized velocity, is nothing but partial derivative of Hamiltonian with respect to momentum, that is generalized momentum, which is very important. qi dot is equal to dou h divided by dou pi. And one more important equation is pi dot. Pi dot, which is nothing but it is a derivative of, it is a derivative of momentum. It is a derivative of momentum, is nothing but minus of dou h divided by dou qi. Qi is generalized coordinate. These two equation of motion is very important while solving the problems. I am taking this theory concept for solving previous year question paper. I am not going into detail. Whichever is important for solving questions, I am taking those concepts only. Okay, now we arrive at a final Poisson's equation of motion. Okay, we have one more important equation of motion, that is nothing but the Poisson's equation of motion. That is a derivative of A. A here, any dynamic variable I can consider. The dynamic variable which is depending on the generalized coordinate, generalized momentum as well as a time. So the total derivative of the dynamic variable, which is nothing but Poisson bracket of, it is a, if I represent the flower back bracket means here it is a Poisson bracket A comma H plus partial derivative of A with respect to time. So if I consider my A to be generalized coordinate means I am doing total derivative with respect to Qi. With respect to Qi means I'll get the solution Qi dot. If I am doing total derivative with respect to Qi, that is a generalized coordinate means I'll get velocity, generalized velocity. So my generalized velocity will be Poisson bracket of Qi comma H. That is a Poisson bracket of Qi and H. Okay. Similarly, if I substitute my A to be Pi, then total derivative with respect to time will be Pi dot. That will be equal to Poisson bracket of Pi comma H. That is a generalized momentum comma Hamiltonian. This is also another form of Hamiltonian equations of motions. Thank you.